everyone, welcome to Allotropes. In today's video, we are going to continue with the carbon and its compound chapter, and in today's video, we'll be discussing about bonding in carbon compounds, its allotropes, and in little bit about saturated and unsaturated carbon compounds. Let's begin with the positive thought, which says that arise, awake, and stop not till the goal is reached. So it's a time for you as well to rise awake and continue doing your studies. Fine? Let's start with the covalent bonding. So whenever we talk about covalent bonding, we have studied that covalent bonding is found in the organic compounds. That means the compounds which are having the carbon as a main element. Now when we talk about covalent bonding, there's a different types of covalent bonding is there. And in that covalent bonding, you can understand there are few different electrons are being shared. Now depending on that how many electrons are being shared, different names has been given, like the single bond. The first one which we'll be studying here is the single bond. So when we talk about single bond, in single bond there are one electron being shared from both the atoms. Okay, you can see here we have taken the example of hydrogen. So when we talk about hydrogen atom, you can see here hydrogen's atomic number is 1. That means it is having only one electron, and that electron is being shared with the other hydrogen atom to attain stability. Now इसमें क्या होता है, एक hydrogen atom के पास एक electron है, दूसरे के पास भी एक electron है. Now उसको क्या करना है, because आपको पता है first orbit में 2 electrons होने से उसको stability मिल जाएगा. So what they do, वो एक दूसरे से electron share कर लेते हैं and they attain stability, and that's how the hydrogen gas forms. Now another example where we can take where the single bond is formed is the chlorine gas as well, where the chlorine, as you're aware, is having 287 configuration, 17 atomic number. Now this again needs one electron only for attaining stability to complete its octet in the outermost orbit. So it do the same thing. It shares one electron with each other and they attain stability, and that's how this single bond is formed. Now single bond is represented by a single line. Whenever we are showing that there is a single bond in between, how do we write? We write H, and then we can write the single bond, single line in between, and then we can write the another atom. Fine. So this way the single bond is denoted. Moving on further, when single bond is there, that means 2 electrons are being shared. Now when the double bond will be there, that means the number will be doubled. Fine. So in this what happens? The 4 electrons are being shared, or the 2 pair of electrons is shared. Okay. So here the 2 pair of electrons is shared, or the 2 electron from both the atoms will be shared. So you can take example of oxygen gas here. Now you can see that oxygen is also having what is the atomic number? That is 8. Okay, oxygen is having the 8 atomic number, and what is its configuration? 2 and 6. Okay, so you can understand that it also needs 2 electrons to complete its octet. So now with this, when we talk about the sharing, so how many electrons it needs to share? It needs 2 more electrons to attain its octet, complete its octet and attain stability. So what is doing? It is sharing its 2 electrons with this oxygen, and this oxygen is sharing its 2 electrons with this one, and that's how they attain their stability, and the double bond is formed. Fine. So this is the way different atoms attain stability. Fine. Moving on further, as the name is indicating, this third type of covalent bond, triple. Triple means 3. Fine. So here the 3 pair of electrons are being shared. So now this 3 pair of electrons, you can understand here. Now when we have taken the example of nitrogen. So nitrogen, you are aware, nitrogen is having the atomic number 7. That means it is having the 2 and 5. So when we talk about this 5, how many electrons it further needs? It needs 3 electrons to complete its octet. Now this 3 electrons has to be shared, because it will be very difficult to pull out those 3 electrons from someone. So what it can do? It can share it with others. Fine? And that's how this triple bond is formed. It shares its 3 electrons with another nitrogen, and the second atom of nitrogen also shares its 3 electrons, and that's how the triple bond is formed and nitrogen gas is formed. Fine. So you can understand this is how the nitrogen is formed, and this is the third type of covalent bonding which is found. Now, talking about further, when we talk about allotropes of carbon. So what are allotropes? Allotropes are nothing but these are the forms in which the carbon is found in nature. That means in nature around us, we have several elements, several compounds formed by those elements. And what in allotropes, when we talk about, this is the carbon only which is found in different forms. And you can understand there are several allotropes which are carbon forms, but the most common is the diamond, which we see around ourselves. Okay, and what is a special thing about allotropes, that they are not different chemically. That means how they will react with other chemical agents, they will react in the same way. But what is different in them? Their physical properties. You can understand when we talk about allotropes, one allotrope is the diamond and the other allotrope is the graphite. So how different the graphite and allotropes, graphite and the diamond is. So you can understand how much they are different in their physical properties, and that's what makes them different. Okay. And you can understand that there are several other allotropes also we'll be talking. Okay, so when we talk about allotropes, they are different in their physical properties. Chemically, they are more or less same only. Now, see, such an irony. If you will take the 10 grams of or 50 grams of diamond and you take a 50 grams of graphite and you burn them, you will obtain the same amount of carbon dioxide from both of them. And that's the reason we are saying that chemically they both will react in the same way, but they are different only physically, right? And we can divide them into two categories. They can be crystalline allotropes and there can be amorphous allotropes. Crystalline means they have the definite crystal shapes, forms, and amorphous means they are not having very definite crystals form, right? So they will be having definite melting and boiling point. That means crystalline will be having a definite melting boiling point, and amorphous does not have a very accurate or exact melting and boiling points. They will vary for a temperature range. Moving on further, these are the two very common allotropes. Okay, first one is diamond. Okay, now this is called as the purest form of carbon in nature. What is there in this diamond? In the diamond, the carbon atoms are arranged tetrahedral shape. Okay, they are arranged tetrahedrally, and that one carbon atom is attached to the three other carbon atoms. Fine. So you can understand the valency of carbon is 4, and here in that 3 carbon atom, one is attached, one in the center is attached to the 3 other carbon atoms. So you can understand the valence will not be complete in that way. How the valency is completed, that it forms one double bond with one and it forms 2 single bonds. So you can understand here in this diamond we have one central carbon atom. It forms double bond with one carbon atom. That means 2 electrons are shared from here, and it forms one single bond with this, and this forms one single bond with this. And you can understand 2, 3 and 4. 4 electrons are being shared. That means its valency is complete. Fine. And that's how this it is arranged in, or how its valency gets satisfied in diamond. Okay. And that's and that having of a single bond, 2 single bonds and 1 double bond makes the diamond very strong structure. Right? And you are aware that this diamond is made in the nature in the coal mines, when there is a lot of pressure from the top and there is a lot of heat coming from the core, and then this change takes place and the diamonds are formed. Okay, and this is a 3-dimensional structure. Okay, now moving on to graphite, which is also called as a black lead. Okay, now in this the carbon atoms are arranged in a hexagonal rings. Hexagonal means 6 carbon arranged in a ring. Okay, now one carbon atom is joined with 3 other carbon atoms here also, just like the above, but the difference in the diamond and graphite is that here only single covalent bonds are there. That means here the double bond is not involved. So in this it will be, carbon will be forming one and then it will be forming and the 2 and it will be forming 3. So you can understand here the 1 electron will be free. So here one electron which is free, here this electron which will be free from this carbon atom will be free to move around in the system. And that what makes the graphite a good conductor, whereas diamond is not a good conductor, but graphite is a good conductor because it has this one free electron to move around and carry the charges. Okay, that's what makes the graphite and diamond different. Now, moving on to the versatile nature of carbon. So when we talk about carbon, we have discussed that carbon form millions of compounds. There are so many compounds which no other element makes that many compounds the carbon along with the other elements makes. Okay, so what is the special property which the carbon has which enables it to form so many compounds? And that property is called as catenation, which we have discussed a little bit in the last video. Catenation means that this is the special property of carbon. Few other elements also have that property, like silicon also, but they cannot arrange in such a long long chains or large numbers as many as carbon atoms can join with each other. So this carbon atoms can join with other carbon atoms in large number to form large molecules. Huge molecules can be formed by joining of carbon atoms. You can see the things around us. This all plastic, polythene, these all are made by the joining of carbon compounds with the carbon in n number. Okay, smaller units join to form the long chains. And that's what makes this carbon so special, that it can form millions of compounds. Right? And the other special property it has, that it is having the 4 valency. Now the one thing is that it's a carbon atom is not so big in size. It is having 6, its atomic number is 6. So it is having 2 electrons in the innermost orbit and 4 in the outer orbit, that is in the second orbit. Now those 4 electrons are quite closer to the nucleus. And when they are closer to nucleus, that means the nucleus can keep a good grip over them. It can hold those. If it will be a bigger atom, the central nucleus will have a lesser grip over the outermost orbit electrons, so that they can go or move out quickly or easily with less energy given. But when we talk about carbon, it is having smaller size, so nucleus has a good grip over those 4 electrons, and the other electrons which are coming to form the bond with it, it can also hold a good grip over them, and that's also makes it a special thing. Fine. And second, and because of that ability, the bonds which are formed are very strong. The electrons will be held together by the nucleus of carbon with a very strong force of attraction. Fine. And now you can see here, when we talk about carbon, the carbon can form the unbranched chains, it can form the rings, so it can form different types of compounds. Here you can see, here these valencies are vacant, means here some atom can join, like it can join with the hydrogen, it can join with the hydrogen here. To complete its valency, it can join with the further hydrogen atom here. Different atoms, we say that as it is a single bond, which I have indicated here, so it is monovalent atom. Monovalent atom means the atom which is having single valency. Monovalent means the atom which is having single valency can attach here and form a bond with the carbon compound to form carbon compounds. Fine. And you can see here these different types of chains, rings can be formed. Here I have shown you the 1, 2, 3, 4 ring compound. It can be 5, it can be 6, hexagonal, pentagonal, heptagonal, octagonal, like that. Different number of carbons can join with each other to form chains, rings, all that. We will be discussing that in next. Okay. Now first we need to understand that we can which type of bonds are present in that particular compound. Accordingly, we can divide the carbon compounds into these 2 categories. These are saturated and unsaturated carbon compounds. Now, what are saturated, what are unsaturated? Saturated carbon compounds means, normally you would have seen this word when you are talking, when you will see the label of your oil or something which you buy from market which has oil or ghee or butter in it, then it will show you unsaturated compounds, saturated part, unsaturated part. So you can see on that label of that nutritional information on your oil packets or something. So what is saturated word? Okay, so when we talk about saturated carbon compounds, that means these are the compounds formed of carbon which are having only single bonds. Okay, so these will not be having double bond, they will be having only single bond between the carbon atoms. They will be those compounds which will have only single bonds in them, they will be called as saturated carbon compounds. This has come by mistake. Okay, so when you can see here, this is a methane molecule. So when we talk about methane, you can see here this is one carbon atom which has joined with the 4 hydrogen atoms. Okay, and you can see here it is forming the single bond. That means 1 electron of hydrogen and 1 electron of carbon will be shared in this bond formation. Okay, so when we talk about next about unsaturated carbon compounds. Okay, unsaturated means which are not saturated. That means they will not be having single bond. That means they will be having double bond and triple bonds. Okay, so it is not that unsaturated cannot have the single bond, but there will be presence of double bond or triple bonds in those compounds, and that's why, and we call them unsaturated carbon compounds. Right? So these unsaturated carbon compounds are having the double bond or triple bonds. Right? Like for example, we can take the example of ethene. Okay, so you can see here in this two pairs of electrons are being shared in the double bond, and then third and then fourth will be shared here. So that's how the valency of carbon get completed here. Fine. We can see the structure further by this way also, by this electron dot diagrams also, or Lewis symbols also. You can see here in the methane. So there is one single carbon atom which has joined with 4 hydrogen atoms, and from carbon 1 electron and 1 electron from hydrogen has been shared in this single bond formation. Similarly here also 1 of carbon, 1 of hydrogen. This 1 electron of carbon and this 1 electron of hydrogen. This one is of hydrogen, this one is of carbon. In this way you can see that the bond has formed and this methane compound has formed. And similarly in ethene, when we talk about ethene, which will be an unsaturated carbon compound because it is having the double bond. Now you can understand here when we are talking about double bond, we have shown that here 4 electrons are being shared, or the 2 pair of electrons. When you remember about double means 2 pair, triple means 3 pair, single means 1 pair. Okay, so remember from that way. Okay, so 2 pair of electrons are being formed in this, being shared between 2 carbon atoms here. Okay, and the other valencies are satisfied by the formation of single bond between hydrogen here, and hydrogen here. And that's how the saturated and unsaturated compounds are formed. We'll be taking in the next videos further detail about these structures, how they form the long chains, rings, and how those different structures are. Okay, that's it for today. If you have any question, you can write in the comment box. You can share it with your friends, and if you like the videos, you can subscribe to the channel and keep watching, keep learning, stay happy, take care, bye.